Hey learners, welcome back to my channel Maths Made Easy with AB. In the first part, we saw an introduction to modular function. This is a continuation of the first, so if you have not seen the first part, do watch it for better understanding. Let's get started with the second part. Let us look into another example. So, say for example, somebody gives you mod x is less than 2. Say this is the question that has been asked and somebody is asking you for the solution. So, let me illustrate this again with the help of a graph. Y is equal to mod x. So, this is the graph, y is equal to mod x and y is equal to 2. So, I told you whenever you get a solution, somebody is asking you for a solution to this, you need to plot this side of the graph, you need to plot this side of the graph, whatever be this symbol. This can be equal to, this can be less than equal to, less than, greater than or equal to, sirf greater than. So you can get anything over here. So let us understand, say this is y axis, this is x axis, y is equal to 2 you have to plot, and this is y is equal to 2. This becomes y is equal to 2. Let me just write it down. Y is equal to 2. Yeah. So let us understand. So what it is saying is this y is equal to 2 at which places will give more value than this. So you have to see where the graph of y is equal to 2 is lying over the graph of y is equal to mod x. So I'll tell you which are the points. So I have plotted this y is equal to 2. Let us see the intersection point. This is one point of intersection. This is one point of intersection. If the question would have been equal to, simple answer would have been at two places. There are two solutions. One is x equals 2 and one is x equals minus 2. If the symbol would have been equal to in between. But since it is less than, so you have to see at what all places is the graph of y is equal to 2 more than y is equal to mod x. Clearly this is the point. I'm just showing it to you. This is the point. I'll just highlight it with a different color. So from here till here you can see that the graph y is equal to 2 is greater than y is equal to mod x. Because if you go this side, means if you go this side, then you see y is equal to mod x will fetch you more value than y is equal to 2. So y is equal to will fetch you 3. It will fetch you 4, 5, 6 and it will go to infinity. So here the graph is fetching you more value, but in between this if you see y is equal to 2 is always giving you 2 value, but y is equal to mod x, it will give you lesser value. So at one it can give 1.9, it can give 1.8. So here it is less. So the solution is in this position, in this point. So basically it doesn't include minus 2 and doesn't include 2, but all the values, real numbers that exist between minus 2 and 2 is the solution. So you need to understand x here lies in between 2 and minus 2. So simple, this is the solution. This is the solution for this answer. So if somebody asks you how many solutions, so there will be infinite numbers between minus 2 and 2. So the solution is x lies in between 2 and minus 2. Let us understand, take an example. Say the question was mod x is less than 2, right? So we are verifying if it is correct or not. So x lies in between minus 2 and 2. Let us take an example 0, which lies in between minus 2 and 2. So is mod 0, which is 0, is 2 greater than 0? Yeah, right. So this is the solution. If the answer would say somebody gets a different answer, say somebody writes 4. So mod of 4, is it greater than 2? No. So that is wrong. So this is the correct answer. X lies between minus 2 and 2. We will see further examples how it is. So you need to take note of this arrow. This arrow will be not including 2. This arrow will not be including 2 and not be including minus 2. If they would have included 2 and minus 2, the symbol would have been changed to this. But this is not the case over here. This is simple. This is not for this question. We'll take other examples and you will understand. Here the answer is x lies in between 2 and minus 2. This can also be written as like this. You need to take x belongs to minus 2 comma 2. So this is another way of writing this. So these are the two ways by which you can write, and this bracket means minus 2 is not included. If the bracket would have been this, the third bracket which we often call minus 2 and 2, this means that minus 2 is included, which is not in this case. So here it will be minus 2 and 2. So you understand the difference between the brackets also. We'll take more examples and understand in subsequent problems. So let us understand what these brackets signify before we move into other problems. So if somebody says that x belongs to minus 8 comma 7. So what this means is the value of x, if we draw the number line, this is x, this is 0, 1, 2, 3, 4. Yeah, and this is maybe dot dot dot, let's write it 7, and this is minus 1 dot dot dot, this says this is minus 8. So this means that minus 8 is included. This entire value till 7 is not included. So this means this one. So this is how it is written. If the bracket would have been x belongs to minus 8 comma 7 and included, then we would have included this also, and entire this would have been coming into the picture. So let us move into our next example. We already have seen x equal, we have seen the lesser one part. Let us take another example. Let us see mod x greater than 2. Let us find solution for this. Mod x greater than 2. Simple hai. What we have to do is y is equal to mod x we have to plot, y is equal to 2 we have to plot. We have to see the places where y is equal to mod x, the graph lies over y is equal to 2. If it is possible at all or it is not possible, we will see in the graph. So coming to this, let's plot the graph y is equal to mod x. So it is simple, y is equal to mod x. Y is equal to 2, we have already made several graphs. This is the graph of y is equal to 2. If you are facing any difficulty in plotting simple graph like y is equal to 2, simple, the normal line, straight line, 3x plus 2 equals y. If you have problems in this, I will be creating a different video of how to plot graphs, and then we will see into that. Now I am not getting into this, maybe later on I will add videos how to draw straight lines. So I am assuming in this video that you are already aware how to draw straight lines. So y is equal to mod x graph, this is the graph, y is equal to 2, this is the graph, and already told this will be 2 and this will be minus 2. What you have to see is where the graph y is equal to mod x lies over 2. Already told you, this is the portion. This portion you see, the graph y is equal to mod x, this lies over this graph. So the values of x will be here. In between this, if you see, in between this, which is above this, so this y is equal to mod x is here, it lies below. The values that will give is in the y axis is lesser than the value of y is equal to 2, which is above. So here y is equal to 2. So this part is definitely not going to come in the solution. This part, so this entire part is not going to come into the solution. So this is not going to come. And here if you see again this side again the graph is attaining more value. So this portion will also be included, like this portion was included, this portion will also be included. So this portion till minus infinity, this line definitely going to minus infinity, this is going till plus infinity, this is till minus infinity. So these part will be the solution for this graph. So simple, I'll write, how I'll write this? So you can write x belongs to, I'll give you two ways of writing this. X belongs to either it will be from minus infinity till minus 2, union 2 till infinity. You understood this? I have given this because minus 2 is not included. You can see the symbol here. This symbol is not greater than equal to. If equal to would have been there, I would have included 2. Since equal to is not here, it's simple greater than, I have only written this bracket. Same with this, same reason, same logic, and this is the part. So this is how you write where x belongs to, and this is the solution for this. Let us take another example and understand with greater than equal to. Say for example, somebody gives you the question mod x is less than equal to 2. Find the solution. So I'm just dividing it. Mod x is less than equal to 2. So simple, what you will do is you will draw the graph of y is equal to mod x. You will draw y is equal to 2. Just I am writing x, y axis. This is 2. This is, so let's not make it like this. This is 2. and this is minus 2. So where y is equal to 2 is greater than y is equal to mod x, already spoken before. This is the place where y is equal to 2 graph is above y is equal to mod x graph, and this is the solution. So this part, the values of x, this part is going to a solution. So x belongs to, here remember this equal to is there, so it will be this bracket and not this one. So this will be minus 2 till 2. So this is the answer for this graph, and this is the answer for this, and this is the answer for this. So you should be clear by now how we are plotting it. Let's understand, take a different example to make it. So we already saw two examples. Mod x is greater than 2 and mod x is less than equal to 2. So we saw the solution of both. Let us take another example over here. Let us study mod x is greater than minus 2. Let us find the value of this. Mod x is greater than minus 2. So let's understand again. So this is the graph of y is equal to mod x, and for your clarity, let me mark this time y is equal to minus 2 with a different color for your understanding, better understanding. Y is equal to minus 2. So this is 0, this is minus 1, this is minus 2. So this is the graph of y is equal to minus 2. So you can see this is y is equal to minus 2 graph, and this is the graph for x, y is equal to mod x. What the question asks you, for what values of x will this part y is equal to mod x be greater than y is equal to minus 2? So from the graph you can see that this y is equal to mod x is always going to stay above this graph, because this graph is straight, it is always going to stay below, and this is always above. So for any value of x, which means we can also say for any real value of x, this is going to be true. This was very simple one. For any real value, x can be 4. So say for example somebody writes 4 over here, so 4 is always greater than minus 2. Somebody writes minus 4, so minus 4, mod of minus 4, what it is? 4. If we apply mod, it value becomes positive. So if we minus 4, x is minus 4, again this will be true. Minus 4 will become 4, 4 is greater than minus 2. So this was a very simple example which we took, and so this is the solution for this one. Let us take another example over here. Say for example somebody says mod x is less than minus 2. Mod x is less than minus 2. What will be the solution for this? So simple again, let's draw the graph. Y is equal to mod x. So this is y is equal to mod x, and let us draw the graph of y is equal to minus 2 over here. This is y is equal to minus 2, this point will be minus 2, somewhere here will be minus 1. So it is asking for which value of y is equal, for x will this part, this graph will be greater than this graph. This is never going to be true. Already told here before that this graph, this graph or this graph y is equal to mod x is always going to lie above the graph y is equal to minus 2. So this is never going to happen. So here there will be no solution of x. This is never possible. So this is the solution. So we will keep this video up till this. From the next video we will take some complex problems. We will include mod x minus 4, something of this sort, and we will see further example of how to solve critical problems for modulus with further graphical solutions. Thank you so much for watching this video. See you in the next one. Thank you. Do subscribe if you like the video, because we will be coming up with more such videos, and do like and comment on this. I'll get back to you soon. Thank you.